Welcome to Business Analysis Techniques again. This is part 2 of the week 1 lecture video. And I'm still your online instructor, Diana Block. And so this is the second video for week 1 where I want to show you how to complete the last 3 problems, problems 6, 7, and 8. Now on problem 6, you're going to read the instructions there in the blue and you've read the textbook. But just to clarify, I want to put down here that you're going to use the binomial distribution function. There's 2 results in this situation. Either the product is defective or it isn't. So this is a binomial situation. It's either one thing or the other. And so you read about a few different functions in your reading this week, but this problem uses binomial distribution. So I'm going to show you just an example of how to use that. So it tells you that normally 5% of cases are defective, and the firm is going to sample 10 cases, and they have, so we're trying to calculate the probability that none of these 10 sample cases are going to be defective. And so we're going to use the binomial distribution function, and here's how you'll do that. You'll equals binom dist. This is the Excel function we're going to use. Then you open your parentheses. The first thing you're going to enter is what we're looking for. We're looking for 0. We're looking for 0 cases to be defective. The next parameter is how many we're going to test, and we're going to test 10. And normally there's a 5% of all cases that are defective, so that's the next thing we put in is the 5%. According to mine, your percentages may be different. Again, this is just an example. And so then we want to put false because we don't want cumulative on this one. And so there we've got our formula in. And Excel will calculate the probability that 0 cases will be defective. So they've calculated a 59% probability that 0 cases will be defective. So you'll do the same thing in here. The probability that 2 cases will be defective, you'll just enter your binomial distribution formula, put in the information in the order that I gave it. The one that'll be a little bit different is the last one, because it's asking the probability that up to 2 cases will be defective. So that's different than asking if exactly 2 or exactly 0. Now it wants up to 2 cases will be defective. So on this one, you'll use the function exactly the same, but the last parameter you're going to put in true because you actually do want it to be a cumulative result. So that's how you will complete problem 6. Use the binomial distribution function in this format that I've outlined for you here. So then we move on to problem 7. Problem 7, we're looking for a relationship to the average, and you're going to read the box and you'll see that the average sale is 4,700 in this case. Yours might be different. And the standard deviation is 500. So in a situation like this, we're going to use the normal distribution. And you read about that in chapter 2, I believe, from your reading this week. But we're going to use the normal distribution function because we're looking for the relationship to an average. So knowing that the average sale is 4,700 and the standard deviation is 500, we want to calculate in this example the probability that a sale will be less than 4,000. The average is 4,700. We want to see what's the probability that it'll be less than 4,000. So in this case, you'll use the normal distribution function. And so we just type norm dist. And the first thing you're going to enter then is what we're looking for, which is the 4,000. We're trying to see the probability that it'll be less than 4,000. The next thing we're entering is the average. And the average in mine is 4,700. Then we're entering the standard distribution, which in mine is 500. And we're entering true because we want the cumulative distribution. We want it to be less than 4,000, and anything less than 4,000 counts. So we close that off. There's our solution. And so that's how you use the normal distribution function. You can see, if I click on it, you can see up here how I've entered that. So you'll use that function again here and here to get the probability that sales will be less than 5,000 and the probability that sales will be more than 5,000. So this more than 5,000 is going to be interesting because the distribution, or the function, is going to calculate less than 5,000, and what you'll have to do is put 1 minus in order to get the flip side of it. So here's what I'm saying. Your formula is going to say equals 1 minus norm dist, and then finish the rest of the problem. This is what you're going to do on the last one because it's asking for more than 5,000. You'll use that normal distribution function to solve problem 7. Now let's look at problem 8. Problem 8 is a queuing problem. We're looking at the time it takes for something to happen, the timing between events. In this particular case, it looks like it's a call center. And so in a queuing problem, we're going to use the exponential distribution. And again, you read about that in the reading this week, chapter 2. And we're going to use this exponential distribution function to calculate the probability that calls will take a certain amount of time. So the instructions tell us that a call typically takes 4 minutes to complete. So what that's saying is a 4-minute call is typical. So typically you have a quarter of a call per minute. Does that make sense? For every 4 minutes is an average call. So that means in 1 minute you have 1/4 of a call. And we want to discuss this in units of 1 minute. So 1 minute is equal to 25% of a call. And that has to be clear before you can solve this problem. So you go to our function box here, and we're going to type in the exponential distribution function. And the first thing we're going to add in is what we're looking for. And so we're trying to find the probability that a call will take less than 2 minutes. So we're entering 2. Then we're going to enter the average call time. The average call time for a minute is 25% of a call. So I'm going to enter 0.25. That's how much you normally get in 1 unit or 1 minute. And then we want true because we want a total cumulative of anything less than 2 minutes. And then Excel has given us our result, the probability that a call will take less than 2 minutes. And so you'll use that same function. Here you can see how I've outlined that. You'll use that to calculate the probability that a call will take less than 5 minutes and the probability that a call will take more than 10 minutes. So again, this is where we're going to start off with 1 minus and then the function, because we're wanting to find out what it will, the probability that it'll take more. So Excel is going to calculate the probability that it'll take less than 10 minutes, and you'll say 1 minus that to get the flip side of it. So that's how you will solve these last 3 problems. Those are the functions that you will use and how to format those. If you have any questions about this, please send me an email, catch me on Blackboard IM, or even give me a call if that works for you. And I want to make sure that everybody understands how to work all of these problems. With our new 6-week format, there are quite a few problems to work every week. So if you have any trouble at all, make sure you stay in touch with me so that you stay caught up. So in any case, I look forward to talking with you in discussion and getting to know more about you as we go through the weeks. So have a great week 1.